Can you believe it? Can you realize that we, that you and I, that all of us, have actually begun the exploration of another world? Come with us.
Our knowledge of the cosmos is an ever-growing search, with new theories emerging daily and old myths demystified. But we have more definitive ways of understanding the universe thanks to telescopes and space probes such as the Voyagers, feeding us new information from the outer reaches of space. So when an important space probe like Voyager sends never-before-seen data indicating new discoveries, it changes everything. But what has Voyager just discovered, and what does it mean for us here on Earth? Join us as we explore how Voyager just entered deep space and sent back a terrifying message to scientists. The Voyager missions have been an integral part of space exploration for over 45 years, giving us some of the very first and most important looks at the true state of our solar system. But these missions were never meant to last this long when the initial plans for the probe were laid out. Born out of pure accidental discovery, the decision to send out probes in the 1970s resulted when Michael Minovich discovered that a spacecraft could piggyback on the velocity of a planet and slingshot further out into the solar system. This would be made possible by a rare geometric alignment of the outer planets that only happens once every 2 centuries. Using planetary gravitation and velocity, it was suddenly possible to reach outer planets such as Neptune much faster, as fast as 12 years rather than 30. While Voyager 2 launched first on August 20th, 1977, Voyager 1 reached the edge of the solar system first, taking a much quicker route, despite launching 2 weeks after its twin. But the trip to its current position just outside our solar system was indeed a perilous one. Voyager 1 was the first to reach Jupiter 2 years after launch on March 5th, 1979, and Voyager 2 wasn't far behind, reaching the gas giant 4 months later in July of the same year. Using several onboard equipment, both probes took the very first close-up pictures of Jupiter, giving us a glimpse of the famous red spot as well as mapping the Earth-sized hurricanes that plagued the planet's surface. We also got data that showed hints of water on Europa, pictures of active volcanoes on Io, and discovered the largest natural satellite in the solar system, Ganymede. But Jupiter was just a pit stop on Voyager's journey, and soon enough, both probes made the trip to Saturn, with Voyager 1 reaching first in November of 1980 and Voyager 2 almost a year later in August of 1981. The visit to Saturn gave scientists a better understanding of Saturn's 10-hour days and a much more accurate measure of the planet's wind speeds, which could reach up to 1,100 miles per hour, the fastest of any planet in the solar system. While Voyager 2 did a meager flyby, Voyager 1 gave us a closer look at the nitrogenous atmosphere of the planet-moon Titan, as well as discovered 10 new spectacular moons that orbit the planet. But Saturn was the last planet both probes would observe together, as a decision was made to separate both probes. Voyager 1 took an ecliptic turn heading straight for the heliosphere, while Voyager 2 carried on to 2 other planets as planned. By August of 1989, Voyager 2 had made it to Neptune, flying just 3,000 miles over the planet's north pole. The flyby revealed the coolest planetary surface in the solar system, with temperatures reaching -400 degrees Fahrenheit. But data sent back by Voyager 2 revealed that Neptune wasn't as inactive as scientists had previously believed, and the surface was filled with Earth-sized storms and fast-moving clouds of ice. But while the data on Neptune was indeed revealing, it left the question of how such a planet with barely any solar energy reaching it could form and maintain such dynamic weather. However, answering that question would be left to future probes as Voyager 2 left the blue icy planet, making its way to the opposite edge of our solar system. By December of 2004, data received from Voyager 1 suggested that the probes had reached the part of our solar system called the termination shock. This is a region in space where solar winds originating from our sun slowed in speeds, from traveling at millions of miles per hour to barely 250,000 miles per hour. Although this might still seem incredibly fast, it pales in comparison to much faster interstellar speeds. This reduction in solar speeds is a result of external interstellar pressure from cosmic rays traveling through our galaxy. But the termination shock simply marked the beginning of the edge of our solar system, and Voyager was yet to cross the threshold. Voyager 1 was the first of both probes to cross the edge of the heliosphere, a milestone it made in August of 2012. The heliosphere is an invisible bubble of charged solar particles exerted by the Sun on the solar system. And just like other invisible forces such as gravity, the heliosphere's magnetic field protects every planet behind it from the violent streaks of cosmic radiation that fill the universe. Scientists made this crossover discovery upon analysis of data from Voyager 1 during a unique solar eruption known as a coronal mass ejection, or CME. During that particular CME, powerful shockwaves ejected from the Sun caused particles around Voyager 1 to vibrate with a much higher intensity. These vibrations observed were much higher than those recorded inside the heliosphere, leading scientists to conclude that Voyager 1 has entered a new uncharted part of interstellar space. Interstellar space is the void beyond the heliosphere, filled with much higher energy particles and a much greater intensity of cosmic rays. It would interest you to know that our solar system is spinning through interstellar space, with the Sun holding the planets together and the heliosphere acting as the protective field that shields the planets, including Earth, from the raw radioactive nature of interstellar space. In anticipation of the Voyager spacecraft reaching this cold, dark corner of space, both probes were built to be powered using radioisotope thermoelectric generators, or RTG, as their source of energy instead of solar energy like most satellites. Each probe is fitted with 3 distinct RTGs, all of which use powerful plutonium as their fuel source. This was a remarkable choice because as the plutonium isotope decays over time, it releases significant levels of heat that each probe then converts to electrical energy. But regardless of the highly efficient nature of this energy source, it can only last for so long, as scientists have already determined that the Voyagers are currently running on less than 50% of power. But power consumption happens to be the least concern of the controllers over at NASA, as Voyager 1 recently encountered what scientists could only describe as strange: the glitch. With Voyager 1 currently at 14.5 billion miles away from Earth, mission controllers over at NASA expect some delay in receiving data from the spacecraft, with data taking as much as 21 hours to reach Earth. But while the spacecraft appears to be operating properly, scientists discovered some anomalies in the data relayed in the past few months. It appears Voyager 1 was unable to resolve its location in space and gave no indications of going into safe mode. Project manager over at NASA's Jet Propulsion Laboratory in California, Suzanne Dodd, gave a statement. "A mystery like this is sort of par for the course at this stage of the Voyager mission. The spacecraft are both almost 45 years old, which is far beyond what the mission planners anticipated. We're also in interstellar space, a high radiation environment that no spacecraft has flown in before." After much needed scrutiny of the data from Voyager 1, it was realized that the glitch was from the spacecraft's Attitude Articulation and Control System, or AACS. This system controls the orientation of Voyager 1 and its antenna. This explained the disorientation of Voyager 1 but not the data glitch. The spacecraft was still sending and receiving data at the expected pace and signal strength, only the data coming through was basically classified as junk telemetry data. While Voyager 1 was giving mission controllers over at NASA a hard time, Voyager 2 was still functional in all its systems, having crossed the heliosphere itself in 2018. But although Voyager 2 was still functional, its power levels were on a steady decline, with mission team members having to turn off non-essential systems and components to save power. The team estimates that at the current rate of power reduction, they can only hope to keep it functional up until 2025. After months of receiving junk data with no apparent way to fix the probe, Voyager 1 began sending back clear telemetry data after one last attempt to fix it. The team over at NASA realized that the spacecraft was sending data through a corrupted onboard computer that had malfunctioned years ago. This computer in turn corrupted the data being sent, resulting in the months of junk telemetry data the team had to contend with. But according to NASA, once Mission Control discovered the probe was using a corrupted computer, all they had to do was simply send a command to the spacecraft to forego the dead computer and use the right one for data transfer back to Earth. According to NASA, the problem has a low-risk fix, and all it took was a little patience for the 22-hour radio signal to reach Voyager 1 and have the probe execute the command flawlessly. But with the data glitch on Voyager 1 now resolved, there still begs the question, what prompted the spacecraft to switch from its regular computer to a dead computer that has been out of commission for years? A statement from the Mission Control team states, "We're happy to have the telemetry back. We'll do a full memory readout of the AACS and look at everything it's been doing. That will help us try to diagnose the problem that caused the telemetry issue in the first place." Although NASA still hasn't revealed what they believe caused the glitch on Voyager 1, other scientists have speculated that the spacecraft might have come in contact with some form of radiation that might have caused a system switch. This is propounded by the fact that Voyager 1 has been in interstellar space much longer than Voyager 2 and has probably come in contact with cosmic rays and particles that we haven't been able to study here on Earth due to the protective barrier of the heliosphere. The Voyagers might not be fully prepared for the unknown, volatile and raw nature of interstellar space, and we may very well experience more data glitches as more data rolls in. What do you think caused the glitch on Voyager 1, and do you think Voyager 2 might encounter a similar case? Let us know in the comments below, and we'll see you in the next video.